something downwards as positive or negative. What matters is that you are consistent throughout your calculation. For example, if you decide that downward forces are negative, for example, such as this one, then you have to make sure that every vertical force that you apply follows that rule, including reaction forces and internal loads. And the same goes for bending moments. Clockwise or counterclockwise doesn't matter. This is clockwise, and this is counterclockwise. It doesn't really matter what to choose as positive or negative, as long as you're consistent and you use that same definition for all moments and all forces. And there are three main types of external forces that we usually consider. First of all, we have point loads, which is also called concentrated loads. For example, if you have a concrete slab like this, and you have a column, so this column goes up. So we have a column like this. And this column is carrying some type of load from above. So it will be a very concentrated load on the edge of this slab in that case. So that is what a point load is. Secondly, we can have distributed loads, which is uniform, can either be uniform or varying. So I will show you two examples. Uniform loads are loads that are distributed like this, and they have the same magnitude throughout the entire length. While varying loads that are distributed can be, for example, like this. They are more intensive here, they are more intense here, and they are close to zero here. And what can this be? This can, for example, be if you have a wall here, and the wall is carrying load from the roof. And this wall is throughout here, throughout the entire length of the slab. So in that case, you will have load that is distributed along here. And the same way, you can also have an area load, which is also a type of distributed load. So you can have a load distributed over an entire area, which could, for example, be furniture load or even dead load. For example, the dead load of the slab. And lastly, we also have moments, which is pure rotation, which could be a twisting or a turning force, like when you try to rotate a beam. For example, here, if you have a beam like this and you try to rotate it in some kind of direction, and then it deforms in some way. And all forces can be broken down into a combination of this. So for example, it's very common to have a beam like this, with a point load in the middle, call it P, a distributed load, call it Q, and a bending moment, call it M. But how do we know the reaction forces of each support? We know in these cases where we have statically determined beams, then we can find them by three equations, which is horizontal equilibrium, vertical equilibrium, and also moment equilibrium. So what does horizontal equilibrium mean? It means that the sum of all horizontal forces from 1 to k, for example, is equal to 0. And the same way for vertical equilibrium, we have that the vertical, let's call it Vi equal to 0. And the moment, so the sum of all the bending moments L have to be equal to 0 as well. And I will provide examples in future videos about how to practically solve these equations. But for now, thank you for watching Structural Simplified, and if you found this helpful, feel free to like, share or subscribe, and I'll see you in the next one.